Yeah, welcome to IoT Users Club, and for one more session on STM32. So generally, we see Arduino is a platform we go for experience there, but once you learn Arduino, so you want to know STM32 is the right one to explore. And we have Raj Sumant with us. He is one of the friend and who is associated with IoT Users Club from the starting stage. So he is working in TCS and pursuing his MTech. As part of his research project he is doing research on STM32, and he will be sharing the knowledge which he has gained to our IoT Users Club members on STM32, where you can use as a replacement board in the production environment. Welcome, Raj Sumant. So over the session to you.
Hello. So I'll share my screen with all of you. I hope the screen is visible. Okay. Hello all. My name is Sumant, and today, as part of the IoT Users Club session, we'll be discussing on STM32 and view STM32 as a potential replacement from the regular Arduino boards that we generally use. Now, the thing with Arduino is that as many of you...
Raj, sorry to interrupt you. Can you mute YouTube video streaming? Because the sound is recording here.
Are you talking to me?
Yes.
I think...
YouTube is playing. Check the window where YouTube is playing.
No. There's no YouTube playing at my end.
Okay, then it's my end. Okay, sorry.
Okay.
Yeah, sorry, it's it. Okay, go ahead.
Okay. So we were discussing on considering STM32 to be a potential replacement for our regular Arduino boards. Now, when we talk about Arduino, it's a good development board. Like most of you might have used the Arduino Uno to begin your course on embedded systems, because it was designed in such an easy manner that everyone would be able to pick it up, and it was a great product for hobbyists like us. But there are a few flaws or a few loopholes with respect to your Arduino Uno board. Now, our Arduino Uno, it basically has the Atmels Atmega 328p microcontroller on it. Now, this microcontroller is a RISC-based microcontroller. RISC as in reduced instruction set computing microcontroller. And it has various peripherals integrated to it, like it has a few ADC pins, it has a few digital pins, okay, and it has support for timers, which are powered by an external 8 megahertz crystal oscillator that we see over here. Overall, it's a good thing for beginners, but we cannot keep on using the Arduino in our projects because of obvious reasons. Uh, these are not production grade. Like you cannot expect them to last or serve your purpose for bigger applications, or uh, for applications that require some level of robustness. Okay, so so that's one disadvantage that this particular microcontroller development board has to offer. Now, if we want to move ahead one step with respect to developing applications that could be deployed or that could be commercialized uh, at the user's end, maybe in different industries, like the automobile industry, or we have the manufacturing industry, etc. Now, these are industries which operate at various working conditions and various temperatures for that case. Take the example of an automobile industry, or the automobile. Now, your car, as you know, it has various embedded systems on it. Like you have the engine control unit, you have the body control unit, etc. And generally, these are to react to situations um, which are considered to be critical, because we cannot expect any delays to occur, and we cannot expect um, a few things to be waiting to be delivered, etc. To the like the memory, etc. to be delivered to the CPU. It has to be almost real time, and Arduino, as you know, it cannot be real time. Okay, so for these kinds of applications, we'll have to go and implement something which will give us the real-time experience. Okay, so we have such kind of critical applications, and Arduino will not be able to support in those cases. So for in those cases, you will have to upgrade to a robust architecture. Okay, and ARM is one such robust architecture that the industry supports, and it's a widely used architecture in multiple industries, like for example, in automobiles, in you name it, you have it. Okay, so that's how ARM um, has gone into the market. We have multiple applications, like even our mobile phones, for that case, are powered by ARM. Now, today we are going to discuss about the STM32 microcontroller. Okay, so the STM32 microcontroller is actually following the architecture of ARM. Okay, so first, let us see why we have seen why we have to switch to ARM, and today we'll see the introduction to ARM. Okay, and then I'll be introducing you the STM32 microcontroller. It's a product of the ST Microelectronics company. Okay, so and then I'll also be discussing various other ARM microcontrollers in the market, and then we'll see a couple of examples, a couple of development examples on how you can use the STM32 to develop some very good applications. We'll explore a few of its peripherals, like the UART, timers, low power modes, etc. And then in parallel, we'll start making comparisons with our regular Arduino. Uh, so we'll see how well ARM or the STM32 can fare with respect to the Arduino, and why it is it is a robust framework, and why it has been such a successful uh, microcontroller with respect to production grade applications. Now first, let us see what is ARM. Is it a microprocessor or microcontroller? But what is ARM exactly? So there's a British company called as ARM Holdings. Okay, so ARM Holdings is a British company which develops architectures. Okay, so it develops microcontroller architectures and then licenses it to various other companies who again design their own products and implement these architectures. Now, if you want me to name a few companies which buy license of this architecture and manufacture microcontrollers of their own, it could be Texas Instruments, ST Microelectronics, and it is all, and we also have Philips or the LPC for that case. Another popular company is the Nordic Semiconductors, which has gotten its own line of BLE devices which are powered by ARM, known as the NRF 51 and 52. So these are the popular companies which develop ARM architectures and bring out the microcontrollers of their own. Now there's a subtle difference in between a microcontroller and a microprocessor, and the difference is difference being, as most of you people might be knowing, a microcontroller has a microprocessor plus a few other peripherals like a timer peripheral, a UART peripheral, an SPI peripheral, etc. So apart from the arithmetic logical unit as well as the CPU, it has all these peripherals, and that's what a microcontroller is. Now ARM, it could be a microcontroller or a microprocessor. Okay, so ARM it just develops the architecture for the CPU. Now there are various companies which add peripherals. Okay, like the peripherals that I've just discussed, they add these peripherals physically using VLSI and ASIC, and they bring out these microcontrollers to the market. Okay, so that's the basic difference between the microcontroller and microprocessor, and its relativity with respect to ARM. Okay, so we have seen what ARM is. Now let us move ahead with the instruction set of ARM and see how different or it is with respect to the Atmega 328P. Okay, because I mentioned the Atmega 328P because your Arduino Uno is basically containing this particular microcontroller, that is the Atmega 328P, and the architecture is known as AVR. Okay, so Atmel's AVR architecture is being implemented by Atmega 328P, which basically follows RISC, but ARM is but different. Okay, now many people might be googling ARM and one of the first definitions that or the abbreviations that they might receive for ARM is Advanced Risk Machine, ARM, Advanced Risk Machine. And a few people might also get carried away by the term risk, and they might think that ARM is a risk in nature. Okay, but it is not. It is different. Okay, ARM is not risk. It is somewhere, or you can think of ARM as a combination of both risk features as well as CISC features. Okay, we'll see that why it is a combination of these features when we discuss the instruction set of ARM. You'll find it more clear. Okay, so the ARM instruction set, it differs from the pure risk definition in several ways, and let us see how it differs. The first one is that we have a variable cycle of execution for certain instructions. Okay, now what does this mean? Now we know that all our microcontrollers are powered by a clock. Okay, so there's an oscillator which actually counts or tells your CPU that one cycle has been completed and you need to load the next instruction. Okay, so in general, your RISC machines, they take one cycle, one such CPU cycle to execute one instruction, but here we have a variable cycle of execution of for certain instructions. So that's one point of difference. Okay, ATmega 328PB in RISC. Okay, first is the first difference that between an ATmega 328P and an ARM is that we have a variable cycle of execution of certain instructions, something that is not possible with respect to ATmega 328P. Now, some of you might get might be feeling that if ATmega is able to process instructions in a single clock cycle, then isn't it much more advantageous as compared to ARM? Okay, so you will get to know this difference on why ARM is a bit better than ATmega after we discuss a few other points. Okay, but I'll certainly bring it to you on why it is a bit better. Okay, so let us see the features of the instruction set of ARM. Okay, the first feature is that there's an inline barrel shifter. Okay, leading to more complex instruction. Now, what is a barrel shifter actually? Okay, so we have various instructions of a microcontroller. Okay, instructions like with respect to basic English, you might understand an instruction is nothing but something that you give, and your machine or the receiving end, it should process this thing and it should give you an output. Now, there is an inline barrel shifter, okay, which stores these instructions. Okay, so which is nothing but I'll just show it to you on how that will actually look like. Okay, so this is the core data flow model of an ARM. Okay, now we have various registers. Okay, and as you know, every instruction goes through these registers, and when a barrel shifter is actually added in front of a in front of an ALU. Okay, ALU is the arithmetic and logical unit, and using this ALU, we generally perform our various arithmetic operations like add, subtract, etc., as well as a few logical operations. Okay, now when you add this barrel shifter in front of the ALU, which is this gives you some additional functionality. Okay, so this expands the capability of many instructions. Okay, because when you can store multiple instructions and shift them, like the speed of execution, it will be a bit faster when we have this kind of architecture. Okay, so that's the advantage that ARM has to offer. Okay, so it has an inline barrel shifter, leading to more complex instructions. The second one, the second advantage that ARM has to offer is a thumb 16-bit instruction set. Okay, now when we are talking about ARM, we generally have various various instruction sets. Okay, and in general, when we deal with latest microcontrollers of ARM, it is generally the 32-bit microcontrollers. Okay, so but ARM, it has support for a special 16-bit instruction set. Okay, there's a 32-bit instruction set as well. So a 32-bit instruction set is nothing but your instructions, they will be of length 32-bit, but we also have another special instruction set known as the thumb instruction set, which is 16-bit in nature. Okay, now what is the advantage behind having a 16-bit instruction set? It generally improves the code density. Okay, code density is nothing but, suppose say you have 100 lines of code, and in those 100 lines of code, suppose say you can have like when you convert these lines of code into assembly language instructions. Okay, suppose say you get 200 instructions. Okay, from your C program, if you just convert these instructions, like they will be getting converted into say 200 instructions if it is say 32-bit instructions, and they might occupy a certain amount of RAM. Okay, so these 200 instructions you will have to load into RAM, and these 200 instructions, they might occupy say X amount of RAM. Okay, but if you go with 16-bit instructions, you can store many more instructions in that X amount of RAM itself. Okay, because we are reducing the instruction size by half, and this improves the code density, which means the number of instructions that you can store in a certain amount of RAM gets increased, okay, by over 30%. Okay, so for the same amount of RAM, we are able to store many more instructions. That is the advantage of ARM. Okay, when you want to um, reduce the code density, you can go for thumb instruction set. When you want to use put it to use on a regular way, model, then you can use the regular 32-bit instruction set. So this gives you some additional flexibility. Okay, because when we are generally talking about microcontrollers, one thing that affects our production cost is the amount of memory that we choose. Okay, so if we are bound by the constraints of the amount of money that we will have to spend on the microcontroller, okay, we cannot be choosing a costlier microcontroller just because your instructions are occupying certain space. Now, with respect to ARM, you can compress those instructions by just following the thumb instruction set, and you can reduce your code density and thereby reduce the cost of your product. Okay, so that is the second advantage that ARM has to offer. You do not have this kind of flexibility with respect to your Arduino. Okay, the next comes conditional execution. Okay, conditional execution is nothing but an instruction can only be executed when a specific condition has been satisfied. Okay, and this feature actually improves the performance and code density by reducing the branches of instructions. Okay, so when you have multiple branches of such instructions, okay, your performance gets degraded. But when you have conditional execution, then you can skip a few you can skip a few instructions, and you can also reduce the code density in that way, because when we have conditional execution, you need not load those instructions into your RAM. Okay, so when we do not have to load those instructions into the RAM, that means whatever instructions that we require only will get loaded, and this will ensure an effective utilization of the RAM that is present in our microcontroller. Okay, so this is another another advantage that ARM has to offer. Now, this is something lacking when primitive microcontrollers like the Atmel. Okay, there is support for conditional execution, but it's not up to this level. Okay, that it can reduce the code density and all. Okay, so that is why ARM is quite more successful than your Atmel microcontrollers. Okay, then so since these are the various advantages that the ARM has to offer, you can substitute your regular Atmega microcontroller with an ARM and get these additional features, and you can make your product production ready. Okay, so this briefly explains us why ARM is of superior quality as compared to our Atmega microcontrollers. Now we have various flavors of ARM. Okay, so now when you are making a sudden shift from Arduino to ARM, okay, or ARM based microcontrollers, then the nomenclature of ARM it might be a bit confusing for you. Okay, but it is all simple when you know what um, uh, what keyword stands for what. Okay. So over the years, we have multiple cores of ARM being released. Okay, we have the quite successful ARM7 TDMI. Okay, that was launched in the year 1998 or so. I don't exactly remember the year, but it was in 1990s. Okay, and from that version of ARM, it has we have advanced to multiple cores. Today, popularly we use the Cortex M, Cortex A, Cortex R kind of core. Okay, um, so uh, we have progressed a lot with respect to the cores of ARM. Okay, but we'll have to concentrate on three major flavors of ARM, and that will actually make our job quite easy. The first flavor is the Cortex M. Okay, the second flavor is the Cortex A, and the third flavor is Cortex R. Now the definition is quite simple. M stands for microcontroller. So Cortex M is, or whatever you see for ARM Cortex M, it is a microcontroller. Now we have the different flavors with respect to Cortex M as well, like the ARM Cortex M0, M1, M2, M3, M4, etc. Now we have another version or core of ARM known as the Cortex A. Now A stands for application. Okay, it's an application specific thing. Okay, so in general we use Cortex A with our smartphones. Okay, for one such example that we can quote is the Qualcomm's the company Qualcomm. It basically buys the license of ARM from ARM Holdings, and it has its own brand of processors like the Snapdragon, etc. So it's an entry-level ARM system on chip for built for Android smartphones, and it uses Cortex A. Now we have the third flavor known as the Cortex R. R stands for real-time applications. Okay, R is real-time applications could be your defense applications, or something which is used in the industries where timing is of utmost importance, and we cannot afford any delays. For such applications, we generally use the Cortex R. Okay, but for the purpose of us substituting the Arduino, we generally can concentrate with the Cortex M. Okay, if we want to use ARM as a regular microcontroller for a few applications, okay, that your Arduino can do, then I recommend you to use the Cortex M. Now, not only these things, we have multiple other variants or cores of ARM as well, but these three are generally quite popularly used in the industries these days. Okay, so that tells us briefly on why ARM is quite popular these days with respect to the industry, and why it could be a potential substitute for productionizing your applications that you have built with Atmel. Now, let us move on to the next section of our today's discussion, that is with respect to the STM32 brand of microcontrollers. Okay, so there's a company called as ST Microelectronics. Okay, so let me just show it to you. ST Micro. Okay, so ST Microelectronics is a company which which I have just discussed, that it buys license of the architectures of from ARM Holdings, and then it brings out its own microcontrollers. Okay, and the popular brand of microcontrollers that it releases is the STM32. Okay, so there's this popular microcontroller called as STM32, which is ARM based. Okay, it is based upon the Cortex M. Okay, so we have this Cortex M1 or M0 microcontroller, and today we'll be seeing a specific part of the STM32, and I'll be using this STM32F103 kind of microcontroller in our today's session. Okay, so it will be something like this, as shown in the figure over here, or you can just see the thing that I am holding. Okay, it is quite similar to what you see over here. Okay, so this will be the microcontroller that we'll be using for today's session, and for using this, since we are talking about programming it or having it as a potential replacement for Arduino, okay, we'll see how well we can use this microcontroller, and let us also try comparing it constantly with our Arduino and see how we can develop the application for the STM32 microcontroller. Okay. Okay, so I have placed the reference manual for this microcontroller over here. Okay, so if you want the reference manual, you can just type reference manual, and you will get the reference manual for this one. Okay, so you can just download this thing, and you can start using it. Okay. Okay, so this is your reference manual. So if you're stuck at any point, or if you're stuck at any peripheral, you can just quickly refer the reference manual, and it will teach you on how effectively you can use the STM32. Okay, and then I have also embedded the data sheet so that you can see what all peripherals that are present in the STM32F103 brand of microcontroller. Okay, you can just use these two references to basically read more about this microcontroller and explore what all features it has to offer. Now, traditionally we are like, if you are a hobbyist and if you are just starting to get hold of Arduino, and if you are wanting to shift to the STM32, then uh, reading these data sheets or reference manuals um, could be painful for you, because maybe you're not accustomed and maybe you're a bit new. So the main aim of today's session is to introduce you to a few tools or hacks that can give you the feel of an Arduino. Okay, so that you can just do things that whatever you have done using your Arduino, and make it and keep it simple. Okay, do not complicate yourself. Okay, so for that purpose, I'll be introducing you to the Cube MX tool. Okay, so Cube MX is actually a tool, a proprietary tool of ST Microelectronics. Okay, now what is Cube MX? Cube MX is actually a code initialization tool or a code generator. Okay, now one good thing with respect to Arduino is that we can generally import a few libraries. Okay, and we can just start coding right away. Okay, and when we import these libraries, it basically does most of the part for you. Like, it initializes your registers, it initializes, like, it gives you all the basic settings. All you need to do is just call uh, those methods or functions, and most part of it will be done for you. Okay, but if you do so, you will lose the freedom of controlling your microcontroller at like as per your will. Okay, because we generally when we do development with respect to Arduino, we do not have the control to various features. Okay, and we generally stick to defaults, and we generally tend to write a few buggy lines of code. Okay, this is something that you will have to avoid with respect to the development in STM32. Okay, and since we actually want to step one level ahead, okay, we will be start using the various tools that are supported by ST Microelectronics. Now, one good thing is that if you are well versed with Arduino, and if you still want to use the Arduino IDE for developing applications on STM32, then yes, you can still do it. Okay, now let us see how you can use the Arduino IDE itself for your STM32 microelectronics. Okay, now there is one simple thing that you will have to do. Okay, let me just show it to you. All you need to do to set up STM32 for Arduino is that you can just click on File, then go to Preferences. Okay, and inside Preferences you will have this Additional Boards Manager URL. Okay, and if you want to do something with respect to STM32, then you can just copy this and this URL and you can paste it over here. Okay, now if you have multiple other boards, like if you might be using the Node MCU, or you might be using the ESP8266, ESP32, etc. Now if you want to use STM32 as well, all you can do is you can separate these URLs by a comma. Now if you can see over here, I have downloaded or I have included the board for STM32. Okay, so this is my URL, and if you want to see what this URL actually contains, then you can just use open it. So this is a JSON which basically contains all these information regarding the boards. Okay, so you have the discovery board, like you have various flavors of STM32, and all those flavors are actually included over here. So you can just Google for this STM32 Arduino link. Okay, or you can just use this link that I have shown you guys over here. Okay, so and you can just configure it in this way and click on OK. Then the next step that you will have to do is you can just go to boards and click on this board manager. Okay, so this once you have pasted that URL over there, your board manager will get configured, and you can just type for STM32. Okay, and you will have various versions, okay, showing up over here. So depending upon the type, you can just install the board of your choice. Okay, now for this, for today's session, I am using the STM32 F103. F1 is the model that I'll be using today. Okay, so that's why I chose the STM32 F1. I have already installed it. So let me just stick to it. If you are doing this for the first time, then you might want to do this installation step. Okay, now once you are done with the installation, then what you can do is you can just go and you can just select your board. Okay, and now I have chosen the board to be STM32. Yeah. Okay, so you have multiple boards over here. I've chosen the generic STM32 F103C series. Okay, but because my microcontroller is basically based on that one, and the variant, as part of the variant, you can just choose whatever variant that you have bought. Okay, and you will have the upload method over here. Okay, now this is where it gets interesting. Now you have the STM32 Arduino bootloader selected over here. Now you have multiple bootloaders available. Like you can upload or you can flash your microcontroller with respect to your the JTAG. Okay, or you can choose to upload with this with the serial port. Okay, so as Arduino users, you might generally be comfortable with by using the USB port, you will be generally uploading your code. Okay, but with the STM32, you have a choice of selecting the either the JTAG. Okay, and now I'll just specify what JTAG will be using and how to upload, or if your code will support you to upload via the USB as well. Okay, but if you can see the various options that you have over here, just give me a minute. Sorry for that. Okay, so now let us see the various options that we have over here. We have the STM32 bootloader. Okay, you can use that one, or you can use the serial. Okay, we have the FTDI as well, so you can use the FTDI and upload it using the FTDI as well, or else you can choose one JTAG debugger like this one. I'm using the ST-Link debugger to upload my code. Okay, or else you also have the J-Link. Okay, J-Link is of Seger electronics, microelectronics. Okay, so we also have the J-Link. Where did I put that? Okay, I'll show it to you. We also have the J-Link, which is a similar kind of debugger. Okay, so you can choose any one of it, but when you want to productionize your code, I advise you buy one JTAG. Okay, the ST-Link is a quite popular one with respect to STM microcontrollers, so you can choose the ST-Link. Okay, so if you want the link for ST-Link, then you can just, you will have various versions. I am using the V2, so this is costing you around 2000 in the retail market, but I think you can get it a bit more cheaper in India. I think it'll cost you around 1000 to 1500 bucks, depending upon where you source it from. Okay, but there are a few sources which can give you at in say 1000 to 1500 bucks as well. So you can just try them out, or you can use one such thing. Okay, so that is how you can configure your thing, and you can load your code. Okay, and now you will have to also change your programmer. Okay, because we'll be using the different JTAG. If you select the ST-Link, then it'll be quite useful for you. Now, with respect to any JTAG, we generally have 4 connections that you will have to make. If you can turn your STM32F103 microcontroller upside down, you will find 4 pins on the back side of it, and those 4 pins will read as 3v3 SWIO, SWCLK, and GND. Now let me tell you what these pins are and how you can use them. Okay, so 3v3 is the 3.3 volt pin. SWIO stands for the software IO part, and the software clock CLK, and the ground. Now if you can see your ST link, okay, you will have you can just refer to the pinout of the ST link, and you will find that the first pin is the 3v3 pin. The 3v3 pin is connected to 3v3 of your STM32 microcontroller, and the bottom row, the entire bottom row is of ground, so you can choose any one and make the connection to ground. Okay, then we are left with software IO and SW clock. Now if you can see the pins over here, pins, I think it is it is written over here. Okay, so the pin outs are actually written over here, so you can just if you can just look into the pin outs, then you will find two pins, SWIO and SWCLK. So just make these connections in this way, and your JTAG debugger, the ST link V2, will be successfully connected. Okay, now if you want to program, then you can just, let's just say, you can just select any one of the examples. Okay, suppose say you like everybody would do, they would start with the basic blink program. Okay, so this is your basic blink program, so you can just compile this thing and you can just upload it to you. It is quite simple. Okay, so that is the basic that you can do with respect to your Arduino IDE, but this will not help us much, okay, because we want to improvise our code. Okay, we want to make use of all the functions or the functionalities that the ARM has to offer. It is better that we ditch the traditional Arduino and move ahead with the tools provided by ST Microelectronics. Okay, so the first tool that we'll be discussing today is the STM32wb MX.
Yeah, Sumant. So
Yeah.
nice to see that. So the STM32 is the big brother of Arduino, more than big brother, you can say. So in the
Yeah.
Arduino IDE, what is the programmer which you have selected for as a programmer?
For the programmer, you can use the okay. So with respect to the programmer, we have various options over here. You can just if you are if you want to dump your code with the FTDI, then you can select the USB tiny ISP. But if you want to dump it with respect to the ST link, then you can just select the upload method as the ST link, and you can right away do this thing. Or you also have ST Visual Programmer software with respect to using which you can dump the hex code that we generate.
Okay, thank you.
Yep. So you can use the STVP to basically dump the code of your onto your Arduino. But since the topic of our discussion today will be with respect to the STM32 on and using the ST-Link itself. So I'll be skipping the Arduino part. I've just introduced the things on how we can do it on Arduino, but let us see or let us explore the various options with respect to STM32.
Yeah. As you said, so whatever board has been introduced, it has to has an Arduino IDE compatibility. So that is why
Yes.
STM32 has provided.
Yes.
But to explore the real thing, STM32, we should go with the real C programming. So which is what industry requires now.
Yes. Yes.
Yeah. Go ahead.
So for using STM32 in a better way, you can just download this tool called as STM32wb. Okay, you can just Google for STM32wb. Okay, and you can just go to the site of STM32, and he will provide you the download option over here. Okay, and you can just set your version and you can start your download. Okay, once you download and install it, this is how your Cube MX will look like. Now we can like the main advantage that Cube MX has to offer us is that it does most of the code initialization for us, something like the Arduino, like when we import various libraries, it does most part of the code initialization, and all we have to do is we just have to write the logic for it. Now the
we have one question, Raj. People are asking whether we can use Python.
Sorry, can you please repeat that question?
We can use Python for STM32 program.
Yes, but I'm afraid the hardware description language layer, the or the HDL, is not that great with respect to Python. So I generally advise you not to use Python and for development of these things.
Yeah, thank you. So generally for hardware, we should go with the C programming language, which is the most popular now.
Yeah.
Yeah.
The main reason being MicroPython or Python for microelectronics is still evolving, and the hardware description layer that is currently written on Python, it is not that good and that refined as C or C++ has to offer. So if you are just wanting to tinker or make a few hobby projects, then you can explore that path, but I sincerely do not advise you to go that path when you are wanting to build some serious applications.
Yeah, thank you, Raj.
Yep. Okay. So this tool, what we have over here is the STM32wb. Now let us see what all options it has to offer us. Now first, as soon as you complete the installation, you will have to first install a few packages. Okay. Now there's an option called as install or remove embedded software packages. Okay. So this gives us various tools and packages which we can explore and we can install. Okay, now as I've told you, we have different versions of STM32 and we are using the STM32 F1 version. Okay, so I have selected the F1 version. Okay, and I have installed this one. If you want to use the F0, you can select that one as well. and we also have various other versions of STM32. Now the STM32L series, L stands for low power mode. Okay, now we have L0, L1 and L4. These are ultra low power microcontrollers. Okay, and you can choose one of these if you are really wanting to conserve power. Okay, and we also have the STM32wb series. Okay, WB stands for wireless Bluetooth. Okay, so as you know, like we have a few microcontrollers like the ESP8266 or ESP32 that comes with a microcontroller combined with a wireless Wi-Fi chip. Similarly, we have the STM32wb, which comes with the Bluetooth low energy chip combined with it. Okay, so when we are trying to develop a few IoT applications, then choosing the communication protocol is of equal importance as choosing a microcontroller to do the processing for you. So if you want to build any edge computing applications or any IoT applications, and if you want to use a BLE, then you can choose the STM32wb. But today we'll the core that these various series have is it could be either Cortex M4 or such case. So what I'll do is I'll just introduce you one thing, the F1 series today, and the others will be quite similar for development purposes. Now we also have the one for ARM as well. Okay, see there's something called as the CMSIS, which is nothing but Cortex Microcontroller Software Interface Standard. Okay, now I'll not be discussing much on this thing for today's lecture because this is a bit advanced topic. And we also have a few other packages known as the Xcube AI. Now one good thing that this STM32 has to offer is that it comes with this proprietary AI tool which allows you to deploy pre-trained models. Okay, suppose say you have some pre-trained models in either TensorFlow or any other package. It allows you to deploy the exact model on a microcontroller as well. Okay, so this gives you the power at the edge, so you can explore this tool as well. Okay, but since we are starting from the beginning stage, I advise you to do the installation of the STM32 F1 package. Okay, so you can just select the F1 package and you can just do the installation. You can just click on install now. I have already installed it, so I am skipping this step. So that is the first step. Now the second step is you'll have to create a new project. Now if you are confused on which one to start, either you can start your project with a basic microcontroller. Okay, either you can choose, if you just know the part number and if you do not know any development board, you can just choose from the part number, or if you have any board like the development boards like the Bluepill is one, like the one we are using today is known as the STM32 Bluepill. and we also have the discovery boards, etc. But let us start by choosing the very basic microcontroller, because if you want to port this code onto your custom board, then it is better that we choose with respect to microcontroller. Okay. And if you choose with respect to microcontroller, it gives you the option of hosting the code on your development board, as well as it will be microcontroller specific, so you need not very much. Now, since I have chosen the option to select the microcontroller of my choice, okay, I can choose from the various packages that are present over here. Now, as I've mentioned, I have the F0, F1, F2, and F3 versions as well. So I can choose from any one, but let me just type STM32 F103. Okay, so I have the F103 C4. Suppose say I want to use this one. It resulted in 49 such things. Okay, now I have various packages over here, like the package like quad fat pack, etc., etc., etc. Like depending on the package, you are free to choose any option of your choice. Let me choose the first option. Okay, and one good thing that the tool offers is the unit price, so that you while building the bill of materials, one great thing that you would like to see is the price that at which you will be buying. Okay, so generally when we are manufacturing things, we generally buy things at bulk. Okay, so if you are buying things at bulk, then it will give you the retail price at which these things are available. So this microcontroller is available at a retail price of $1.67 when we order it for like 10k units. But you can choose various quantities, and you can also find various other sellers who can offer you at a much discounted price than this. Okay, but it will give you the details on how much it will be costing when you directly buy it from STM microelectronics. Okay, and you can also see if the product is in mass production or not, if it is active or not. Because generally when we choose any microcontroller, it could be out of production, and when you are developing with such kind of a thing, okay, and you find out that it is no longer in production, then you'll be losing precious man hours. So it's better that you first see if the product is in mass production or not. Now when you have chosen that thing, then you can just select on start project, and it'll take some time to start project. Okay, so it has this thing. So this is our STM32 F103 microcontroller. Now if you can see what all cores it has to offer, it has the DMA it has the GPIO, it has the NVIC, RCC. Okay, like we have the watchdog timer, etc. Like various options over here. So what we can do is you can choose to select any pins and configure it according to your choice. Now let us see how we actually do it in Arduino, and let us try to compare and implement it on the Cube MX as well. Okay, so when you are doing it with respect to Arduino, for what you generally do is you first select what pin is what. Like if you want to configure that pin as an output pin, or if you want to configure that as an input pin, if it is an analog pin, if it is a digital pin, etc. You generally specify in the setup. Now if you want to do the same, you can just click on any one such pin and you will be given the option of choosing it in whatever mode that you want to use. Okay, so suppose say you want to use this one as a GPIO input pin, you can just select the input. If you want to select it as an external interrupt, you can just select it as an external interrupt, or if you want to use it as an analog pin, you can use it as an analog pin. Suppose say I choose it to be analog. Okay, now my choice would be to choose from the various options over here. Okay, now let us find now the second thing that we generally do in Arduino is we do this thing serial dot begin at some baud rate, say 1115200. Okay, we generally do this, right? So we want to begin the baud rate, or we want to use the serial print commands. Okay, now with respect to microcontrollers, what is actually happening is we are configuring the UART port. Okay, so you'll have to check what pin is actually the RX and TX. Okay, so I have PA3 as the RX pin, and I have PA2 as the TX pin. Okay, now I have multiple UART pins over here. So this is the USART 2. So these two are the RX and TX pins. Okay, so what I can do is I have selected them, then I can just go and check for UART. Yes, in the connectivity tab I have the USART 2. Okay, so what I can do is I can just go to the mode and I can select asynchronous. Okay, and I can just simply enable the interrupt as well if I want. Okay, then you will see the color change over here. These two pins have been configured as UART pins. Okay, great. Next comes okay, let us generate a basic code for it. As like I can just click on, and like I have various other options like the clock configurations and all, I have the I'll have to go to the project manager, give a specific name over here. So let me just give this name as IoT Users Club Demo. Okay, and I can just select. Let me just create a new file, the users club. Okay, and okay, and then I'll have to choose a specific toolchain or the IDE for which I want my code to be generated. Okay, so if I want, I have an option to choose anything over here, but let me choose the MDK ARM v5, that is the Keil version 5 one, and I can click on generate code. It says the firmware package is not available. We want to download it now. Let's say yes. It will download that thing and it will open up.
Yeah, so Raj, so you mean to say what is the difference between the Keil and this QMX?
Keil is a development environment. QMX is the code initialization tool.
Okay, so to initially program with STM32, so we should first start QMX and then go for the list, or how is it?
That is because we want to initialize whatever peripherals that we want to use. Like if we are using timers, if we are using UART, if we are using pin as an input, if we want to use the pin as an output, we can easily configure it in GUI, as we have just seen over here. And now when we are doing it on we'll have to manually type the code, but this, since we are using it using a GUI, things are a bit faster, and they will give it will generate a basic C code for us. Like all the initializations will be done in C, and it will in that. So in that way, CubeMX is useful, and Keil is the IDE, where we edit the code. Okay, it will now generate some code for us. Keil is something with which we will edit the code.
Okay, you mean to say because of using QMX and selecting the pins over here, so the code foot stamp will be very less instead of selecting all the pins.
Yes, yes. I think this is taking a bit of time.
And this is proprietary tool of STM32, or we can use another code which is available.
Can you please repeat that question?
So is there any other CodeMX available, tool available other than STM32 CubeMX?
No.
So this is the one which we should use.
This is a proprietary tool for developer STM microelectronics. Okay. So I'll just hit on open project. Yes, just ready. I'll hit on open project, and it will open up Keil. Okay, so Keil is opening up.
Yeah. We need to separately install both CubeMX and Keil, or
No,
CubeMX installation will get the Keil.
no, we'll have to separately install both of them.
Okay.
We also have the uh, STM32 Cube IDE as well. But I generally find Keil to be much comfortable for developers, because when we are actually developing or debugging the code, Keil has a bit advanced options, and it gives us a better feel. So that is the reason why I am choosing the Keil over STM32 Cube IDE for uh, for editing the code.
Yeah. So Keil is most popular, and in the whenever people are looking for as an embedded engineer, so they ask for Keil program.
Yes. Okay. Now, if you can see, this is how your Keil will open up, and if you can just go into applications and main.c, you will see that most part of the code initialization has been done for you. Okay, now if you can see with our CubeMX, okay, what we have done is we have selected the TC15 as the analog input pin. Okay, and then we have selected the UART as well. So what it has done is it has basically generated most part of our code for us. Okay, now all we need to do is we can just go into our main function. Okay, so this is our main. Now inside our main we can start developing our logic. Now one thing that we have done is we have mimicked the void setup using or we have generally done the void setup as well as including a few header files using CubeMX, and we have the second part, that is the void loop. Okay, we know that void loops is actually an infinite loop which keeps on repeating itself. Now the same functionality is present in here as well. So inside your main you have the while one loop, which is nothing but your infinite loop. Okay, so since you have the infinite loop, like whatever logic that you want to build, you can write it in the while one loop. Okay, so here you can you can start coding for your things. Your basic setup would have been done for you. All you need to do is you can just straight away start your coding from this point. Okay, now let me just connect my debugger to one of the serial port. Okay, so what you can do is you can just go to Flash and then configure Flash tools. Okay, I'll be showing it to you on once you successfully connect your debugger. It should be showing it to you over here. You can just go to debug and it says no ST-Link detected. That is because I have not connected any debugger. Now let me just plug my debugger in. Okay, think it is, yep, it is now plugged in. Now I can go to debug, and here I'll be able to see my device. Okay, it says this is how it will be able to detect my device. Okay, and I have various options over here. Okay, like I can download the entire like once I compile it, I can just download this thing onto it as well, and stuff like that. But if you are a first time user, here you will have to uh, add your microcontroller of choice. Okay, I have added the STM32F10. Okay, I have various options over here, so I can just select whatever thing that I want to add, and it will get added for me. Okay, so I've chosen this one. Then that's pretty much it. That's the setup that you will have to do, and you can also check the RAM for the algorithm, like where is it starting, what would be the size of it, etc. Okay, now I click on OK. I also click on OK. Then I can just go to the various options over here. Okay, now I can just build my thing. Okay, there's an option for build the project. When I do the build of the project, it will like, since you know it is CC cross compiler that we are using it over here, so it will just compile the entire units, and it will generate a hex file for us. All we need to do is we need to dump this hex file onto our thing, and it will start working. Okay, so this will build, and you can just click on the upload button over here. Yeah, this is the load option over that we have over here. So you can just click on this load, and it will basically load this thing onto our microcontroller. That is something similar to the upload button that we see on Arduino. So whatever our Arduino is doing, okay, the same can be seen over here. Only thing is the way in which the buttons will look will be a bit different. Okay, but whatever logic that we want to build will be in C, and will have much finer control over the various peripherals that we want to use. Okay, now if you want to change the baud rate, you can just go to UART init. You can just change the baud rate. Say if you are comfortable with 9600, you can just change it over here. You have the option to choose the stop bits of UART. Okay, and we also have the word length option. Okay, so this gives us much finer control when we do it in this way. But if you see over here, when we do serial.begin, and we generally tend to ignore the various other options that serial.begin has to offer us. Now in Arduino as well, we have choice to check the the number of stop bits, etc., kind of things, but it will when we are doing it using embedded C in this way, it will give us a much finer control of things. So I think let us stop our session at this point, because we have a few practicals to come to do as well. Like I'll teach you how we can use the serial print that you use in Arduino, and let us try to mimic the same using the UART port. Okay, and we'll also explore the low power modes, how we can take our microcontroller to the low power modes, and how we can bring it out of the low power modes, and how we can and I'll also be dealing with the various debugging techniques, since we have attached the JTAG debugger over here. We'll explore the various debugging techniques and see at what level there's a fault in our code, at what level maybe we'll try to generate some memory faults, like out of memory faults. We'll try to catch those faults and see, you might have generally observed that a few in a few cases your Arduino, it might reset itself. Okay, that is because there would be some memory faults in Arduino. Now, when we are using Arduino, you might not be able to debug it properly, and that would be leaving you with some bugs. But when we are dealing with STM32, we'll have, let us try to explore various options on how we can do the debugging and all.
Yeah.
Okay.
Okay. Thanks, Raj. So I think so I'm powerful, and the session is also powerful, and it has some time to get initialized. So as you said, we can cover the other programming, UART and low power modes, and the interrupt what
Yes.
we have asked so in the next coming session. Okay.
Yeah.
Yeah. So thanks for spending time with us. So I would use that club, and so please be subscribe to our channel for the next session on STM32. Thanks. Thanks a lot.